All right, I'm going to get started. Not many people here, but I think a lot of people watch it later. So I'm just going to go over a few things. If August or Madeline or if anybody else has any questions, just feel free to jump in and ask, or you can put them in the chat if you would like. A couple things for this homework, which is also good stuff for the test. Remember, the test is not this week, but it's next week, test 2. Is the stuff that's going to be in this homework you'll see again on the test. So the first thing I want to review quickly is Kepler's 3 laws of planetary motion. All right, the first one is that all planets, and that's not just planets, he said planets, but it also goes for comets and asteroids. Everything orbiting the sun orbits on an elliptical orbit. And if you remember, our elliptical orbit is like an oval. And how it's defined is it has 2 centers. It actually has, they're called a focus, and this is the second focus, or 2 foci, if you pluralize it. And then when you do a ellipse, you have the long way. This is called the major axis. This is the minor axis. And what Kepler said is that all planets go on this ellipse, and at one focus is the sun. So at some time in our orbit, we're close to the sun. When we're over here, we're close to the sun. This is called perihelion, which is the term for closest to the sun in your orbit. And at the furthest point over here, it's aphelion. Okay. All right. Kepler also said then in his second law is that the planets move fastest when they're closest to the sun. So they're moving fastest here at perihelion. They're moving slowest at aphelion. So we don't go in equal speed all the way around. We go fastest at this point. And so we whip around here and then we go slower out here. Now for the Earth, it doesn't make much difference because our orbit is pretty close to being exactly circular. So we're at perihelion, or we're closest to the sun, actually in early January each year. Now, obviously, it's not being close to the sun that makes our season, because in early January, we're in the middle of winter. So that's because we're nearly a circular orbit, and the height or the altitude of the sun in the sky makes a bigger difference on our seasons than being close or far away. Now, if we lived on Mars, Mars gets significantly closer when it's at perihelion and further away at aphelion. And so it makes a bigger difference for Mars. And then Kepler's third law says that p squared equals a cubed. It's just a mathematical equation where this is the period, and this has to be in years, and this is the distance in AUs, where an AU, remember, is an astronomical unit, or it's the distance, the average distance the Earth is from the sun. So the Earth is at 1 AU. All right, so this equation is actually easy to use. So if you know either the period or the semi-major axis, and remember the semi-major axis is half of this axis, so this distance here is A. So if I'd say that A is 4 AUs, yeah, then I can just put this in and say, oh, p squared is equal to 4 cubed. And so you can plug that into your calculator, or you can do it out the long way and you say, well, 4 cubed means 4 times 4 times 4, which is 16 times 4, which is actually 64. And then you have to take the square root to get rid of the squared. So p is equal to the square root of 64, which is 8 years. So the easiest way is to just always have this equation and just plug it into your calculator. Now, it is possible I will give you, instead of giving you A, I can give you the perihelion distance, which is this distance, and the aphelion distance, which is this distance. So we're going to call this distance to perihelion, or dP. We're going to call this distance to aphelion here. Well, notice if I add those together, so that if I can write here, distance to aphelion plus the distance to perihelion has to be equal to 2 times the same on major axis, or it equals the whole thing. So if I add this distance and this distance, I get the whole major axis. But what I want is A, and that's half of it. So I have 2A is equal to that. So if I give you this and I say there's a problem like planet is at 4 AU at perihelion and 15 AU, or actually let's do 14 AU. Try to make an easy number here. 14 AU at aphelion. What is its period? Well, all I'm going to do is say, oh, 4 AU is when it's closest. So that's the distance to perihelion. Remember, I'm using this equation over here now. So distance to perihelion is 4 AU. So I'm going to put 4 in there. Distance to aphelion is 14. And this is equal to 2A. So I add those together. I get 18 is equal to 2. I divide both sides by 2. And I get that A is equal to 9 AUs. And then I plug that into my equation here. P squared equals A cubed. So P squared is equal to 9 cubed, which is equal to 9 times 9 times 9. Okay. And if you plug that into your calculator, or you do it this way, you get 9 times 9 is 81, times 9 is 729. You take the square root of that, and you get P is equal to 27 years. I think. I'm going to check my math real quick, make sure. Sometimes when I do it in my head, I mess up. So let me see, 729. I take the square root of 729. I get, yes, 27. I had done it right. All right, that's how you do Kepler's law problems. Okay, most of it is just understanding the ellipse, be able to draw an ellipse and label these points, the minor axis, major axis, perihelion, aphelion, the foci. Be able to do that and be able to use this equation, P squared equals A cubed. All right, let's talk about planetary configurations. This is very similar to when we were doing moon phase problems. In fact, almost the same. In this case, we're going to look at, let's do a superior planet. Remember, superior planet is any planet that is further away from the sun than the Earth, which is Mars, Jupiter, Saturn, Uranus, Neptune. Remember, for the ancient people, they didn't know about Uranus and Neptune because you take the telescope to see them. So all they knew about was Mars, Jupiter, and Saturn. Okay, but what we have is, here's the sun. Here's the sun. We have the Earth going around the sun right here. And then sorry, that's not the sun. This is Earth. And then we have some planet that's further out here. It doesn't matter which one you pick because it's all going to be the same. Let's say Mars, for example. What they figured out was there's 4 positions where the Earth, the sun, and the planet make a nice geometric configuration. For example, here they're all in a nice line. This is called opposition. Mars tonight is at opposition. And that only happens every couple of years, because by the time the Earth comes back here, Mars is over here. And so it takes us a whole nother year. So every 2 years between Mars being in opposition. Now look at when it's at opposition here. Notice that Earth is actually closest to Mars. Normally, like, Earth would be here and Mars would be over here, and it would be much further away. But at this point, we are closest to Mars. So Mars is the brightest in the sky. It's the easiest to see at this point. And we're passing Mars at this time, so that Mars is appearing to go backwards, or it's making its retrograde loop at the same time it's at opposition. Now we can go the other way when Mars is over here. So this is Mars. When Mars is over here, so that it still makes a line, but now Mars is behind the sun in our sky. This is called conjunction. Okay, and now we can't see Mars when it's in conjunction. In fact, when Mars is in conjunction, it's out of communication too, because the sun puts out so much radio noise, you can't talk to it. So when we have, like right now, they have rovers up there on Mars and they have satellites orbiting Mars. For a while, when Mars is near conjunction, they can't talk with them. We get no radio signals back from Mars. So if you were an astronaut and you went to Mars, during that time, you would be out of communication with the Earth. Now, it depends on how long that is, because what happens is the Earth goes faster. So eventually it's going to come around here and you're going to see Mars, but it can take days or sometimes even more than a couple of weeks before you can be in communication with Mars again. You have to get around the sun. And then they said, okay, look, we can also make a 90-degree angle here and put Mars up here, so that this makes a 90-degree angle, Earth at the center. This is called quadrature, and this is called eastern quadrature. It's eastern because Mars is east of the sun. If you look at the sun in the sky, Mars would be east of it in our sky. And down here, we can put Mars down here. This is western quadrature. All right. Now, the key with this is you just have to memorize those positions. It's just kind of like with the moon, when you memorize the different phases of the moon, just memorize where these 4 positions are. So when the problem says opposition, you know, oh, that means that Mars is opposite the sun. Eastern quadrature means it's up. Western quadrature means it's down. And conjunction means it's on the opposite side of the sun. Just memorize those. Just make sure you know them. All right, so let's do a problem with planetary configurations. So we might say, have a problem like this. What time does Mars set if it is in western quadrature? So how do I want you to do this? Well, if you watch the videos, you're going to do exactly what we did with the moon. You're going to always draw a picture. Here's the sun. You're always going to put the sun and the Earth. And then we figure out where Mars is. Well, Mars is in western quadrature. Well, I know from up here that, oh, western quadrature means that Mars is below the Earth down here, so that this makes a 90-degree angle. Helps if I move it up so you can see it, right? So that this makes a 90-degree angle like this. So here's Mars right here. But then, just like we did with the moon, you have to figure out, well, where is Herb going to be? He's going to be at one of these 4 spots, here, 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 or here, so that Mars is setting. And remember, Mars setting means it's in the west. So I'm going to pick my Herb over here. And remember, you put your Herb on the Earth, and then you draw a line at his feet, essentially the edge of the Earth, and you figure out which way is east and west, and you figure that out by which way the Earth is rotating. Remember, the Earth always spins counterclockwise because we're looking down from the North Pole, so it's spinning counterclockwise. Well, the direction it spins is always to the east. The direction it spins away from is to the west. And so you look here, west is here, which means, oh, it's in the west, so it's setting. That means Herb right here is the right Herb, and the time is noon. So the answer is noon. So Mars in western quadrature sets at noon. Do you have any questions about that? right, let me do another one. Now what we can do is lots of times will combine more than one planet and the moon all at the same time. So we can do a more complicated one like this. It sounds harder, but it's really exactly the same thing, and it's not that bad. So this is how we do it. Let's say we have a problem that says the full moon is rising. Well, Jupiter is on the meridian, and Saturn is setting. What time is it? And what configurations or planetary configurations are Jupiter and Saturn in? Oh, sorry. I just realized I had my view wrong. So now the recording should be better. Focus it. Okay. So I'm going to do this the same way I did the other ones. I'm going to put the sun over here. I'm going to put the Earth here. Okay. And then I have to start reading this and figure out where to put things. So full moon means that the moon is, if you remember over here, the moon has to be full when it's over here opposite the sun. That's what makes it seem full. Okay. And it says the full moon is rising. Rising means the full moon has to be in the east. So let's figure out where Herb is. Well, you got the 4 choices to figure out where Herb is. So I'm going to pick Herb up here. And then I'm going to draw the line at his feet. I'm going to say, oh, which way is east and west? Well, it's spinning this way, counterclockwise. So this direction is east, this is west. So east is pointing towards the full moon. So that means the time is 6 p.m. This is exactly what we did with the moon phases from the last test. Now we know where Herb is. Herb is right here. We can figure out where Jupiter is. Well, Jupiter's on the meridian. Meridian means it's right over his head. So Jupiter's up here. Yep, Jupiter on the meridian means it's directly over Herb's head. And Saturn is setting. Well, Saturn's setting, it's in the west. Well, west is this way, so Saturn is way out here. Okay, then I remember from my chart over here, I said, oh, okay, if Jupiter is up above the Earth, it must be in Eastern Quadrature. So Jupiter's in Eastern Quadrature. And Saturn is over here behind the sun, so it's in conjunction. So that's the answers to this problem are, the many answers are 6 p.m., Jupiter's in Eastern Quadrature, and Saturn is in conjunction. Is this making sense, I hope? A little bit?
How did you get Jupiter in Eastern Quadrature again?
Yeah, okay. So
Since it says rising or what?
no, it says it's on the meridian.
Oh, okay.
Meridian means it's over Herb's head. So once I figured out where Herb was, I just put it straight above his head. So you have 3 choices for any object. They're either in the east, they're in the west or they're on the meridian. And east is the same as saying rising. West is the same as saying setting. And the meridian means overhead. Okay, so those are the terms that will show up in the question. You just have to know what each of those means. So if I say rising, it means it's in the east. If I say setting, it means it's in the west. If I say meridian, it means it's right over his head. Should we do another one?
No, I understand now.
Does it make sense?
Yes, a lot more sense.
Does anybody else want me to do another one? Should I do another one? Let's do one just for practice. All right. I'm going to write it out and you try it and then we'll work it through it together. Okay. Let's say the third quarter moon is on the meridian. While Mars is rising. And Jupiter is setting. What time is it? And what planetary configurations are Mars and Jupiter in? All right, so give it a try. I'm going to give you a minute here, or at least get started on it, and then we'll work on it together. Remember, draw the picture, and for the homework, make sure you have the picture and you turn in the picture with it. Same thing when we do the next test. I need to see the picture, which usually helps you too, because even if you make a mistake, if the picture's right, I'll give you credit. But if it's just wrong, then you get nothing. So draw your pictures. That shows me that you have understanding. Remember, all the pictures start the same. We got the sun, we got Earth here. And then we figure out where to put the other objects. So our first clue is the third quarter moon. And you just have to remember that the third quarter moon is down here. Remember, it goes new, first quarter, full, third quarter is down here. So here's the moon. And the third quarter moon is on the meridian. So that means it's directly over Herb's head. So Herb is right here. I'm going to draw the line at his feet. I'm going to remember the Earth spins this way. So this direction is east. This direction is west. And what time is it when Herb's down here? It's 6 a.m. because the sun is in the east and the sun is just rising. Okay. Now we got to figure out where to put the other planets. So Mars is rising. So rising means it's in the east. So I'm going to put Mars. Mars is over here behind the sun. And Jupiter is setting, so it's in the west. So Jupiter is over here. And now I just have to go back to my chart here and make sure I have this memorized. I say, oh, if it goes sun, earth, planet, make it a line with the earth in the middle, that's opposition. So I'm like, oh, Jupiter is over here, sun, earth, planet. Jupiter is in opposition, which means it's opposite the sun in our sky. It's exactly opposite. So Jupiter is in opposition. It's 6 a.m. Let's look at Mars. Well, Mars is over here. So it goes Earth, Sun, Mars. If I look on here, I got Earth, Sun, Mars. It must be in conjunction. So Mars is over here in conjunction. Okay. So that's pretty much how you do them. If you haven't, you should go outside tonight after it gets dark, like about 9 o'clock or so, and look up towards the meridian. You'll see Jupiter, brightest thing out there. And then Saturn is just off the side of it. It's fairly bright still. And then Mars will be just rising in the sky because it's in opposition. It rises as the sun sets. So you should go see out in the real sky and see if you can pick out these planets. Does anyone have any other questions or anything they want me to go over?
I don't want you to go over nothing, but I was trying to see, like, on the quiz, I remember, like, I think the first question, it asked us something about, the recent quiz, actually. It asked us something about, I forgot. It was a tricky question. It says something, it says paraling or closer to the sun. I remember the two answer choices. And I chose perihelion or something like that, but I thought closer to the sun and perihelion was the same.
It is. Let me,
So number,
I'm going to pull it up right here because, what was it on the latest one, the Modern Astronomers?
yeah, it was that one. I think it was number 1.
Okay, let me see.
Yeah, I think I had the same problem too.
Okay, yeah, here, let me, are you with me here? I'm going to share my screen. I have it pulled up over here. All right, so this was the question you're asking about, right? This one? At what point in a planet's orbit by the sun is the planet moving the fastest?
Yeah, that one.
That one, okay. And the answer is when it's closest to the sun and when it's at perihelion, and half a period after aphelion, it's back at perihelion. And so the answer is actually all of the above.
Mm.
Okay, so what I'm going to do here, where's my stop sharing here? Sorry, I'm going to stop sharing. Remember this right here? So we're back to here. And so it said, oh, when it's closest to the sun, this is when it's moving fastest here, right? Fastest here. So the first answer was at closest to the sun, which is right. Perihelion is closest to the sun, so that one's also right. And half a period after aphelion means it's over here at perihelion too. So all three of those actually said the exact same thing. You're right, it might have been a little bit tricky.
Yeah, that was tricky.
Are there any other questions? All right, are you guys learning anything? Is this stuff new to you, I hope?
Yes, that helped.
All right. Okay, well, I think I'm going to end this unless somebody else has any other questions or anything else they want me to try to explain at this point. All right, we'll see you later. Remember, there's a quiz on Friday, and then the test is next week.